see he's very technical. He wants to become a movie director.
No.
You see a lot of PhDs in the teaching. I think you have noticed more PhDs in the teaching because that's something new at ISS. In the past, they would come and get their doctoral education only. Then that's not a good basis for finding a job later on. We also have to have some teaching experience. Binyam also teaches some classes, and here he also teaches classes. So that you know. It's not that we think that this is beyond the work of a professor, right? I find it very important to do this. But I also want other people to give part in all the work at ISS. Okay. And when you go for the hands-on, here you will be the boss, right? She will be the boss. Good, so here you see this picture, and this is the whole, this is one. This is the thing that we are going to divide. It's the F. Now it has a number. And then you see that they cut it differently. So the first two steps were okay, but then I went on. Half, 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 and here they take a third. And then they take a half. Why they do this? I don't know. I found my way easier. But over here you see 0.0, 0.1, that means a tenth. Right? 0.2, 0.225, it's a quarter. So you see that the decimal way of writing things often is related to the fractions. And as I was telling you, these Greeks, they were thinking that all numbers were there. And then they found something extraordinary. It was about the circle. And I don't know if you've ever heard about the circle, but for the circle you need pi. And pi is a very, very strange number. This is pi. You see, it starts with 314. Do you know in what room you are today?
Why?
Guess why you are in this room? Right? Because it's in honor of this number. And they use it when they calculate circles. And they did this 4,000 years ago. And they could go very far in their calculations. And they were completely shocked because it never ended. We now know that if you have a computer, you run it for 10, 20 years, it will not find the final solution to pi. So it's magic. Still we can do a lot of calculations with it, right? And the reason that I tell it is that you know that there are rational numbers and irrational numbers. Some numbers you can write as a ratio, 27 divided by 7. It starts like pi, 3.14. But if you want to really do calculations with circles, it will not work. There we have the elevator, right? Second floor, first floor, ground floor, -1. This is what you have to keep in mind. You're on the second floor, 1, 2, 3 down, -1, right? Then you're in the basement. Exercises, well, easy one. -3 plus 9, 6. -4 minus 7. Would it matter if I said -7 minus 4? Would it matter? No. 4 plus 3 minus 9? -2. You are at the 4th floor, you go up 3, you go down 9. 4 minus 3 plus 9? Good. You go from 4 to 1 and then plus 1. That's there. Good. So that's something you understand with the elevator. But the elevator also works when we do multiplications. 4 times 5 means you start at ground 0, you go up 5, you go up again 5, you go up again 5, you go up again 5. Can't be done here at the ISS, but you have seen all these high buildings in the Hague. You are on the 20th floor, right? So it means add 4 times 5. What does it mean if we say multiply 4 times -5? Then it means you are on the 20th floor, you go down 5 floors, you go down 5 floors, you go down, so it means, so add 4 times -5. We can also have minus 4 times 5. That's a bit difficult. How do I do minus 4 times 5? But it is the same. It says 5 plus 5 plus 5 plus 5, but there is a minus. And you can also do this for minus 5 minus 4. See? Minus 5 minus 5 minus 5, that's minus 20, but there is a minus, so it becomes a 20. This is what you really have to remember. If you do a multiplication or a division, plus times plus is plus. Plus times minus is minus. Minus times plus is minus. Minus times minus is plus. They say that this is a recipe for love. So if you're the same, but if you have opposing characters, it also somehow gives you a good marriage. I know. My wife hates numbers. She's a lawyer. Yes?
My question is, I've been struggling to find out why minus and a minus is equal. Because it's like negative or negative, and then you say, okay, positive.
There's no problem to see positive and positive. Positive times positive is positive.
Yeah.
No problem there.
Positive,
Positive times negative, also not a problem, right? That is negative. Positive times negative, also not a problem. Negative times negative, right? Now you can perhaps imagine a battery. You have two batteries. Normally, this is plus, this is minus, right? Normally it looks like this. This is how you have to put it in the machine. There will be a wire somewhere here. Actually, it will look like this, and then the machine works, right? The machine will also work if you would do it like this. Okay? No problem. When does the machine not work? Take a look over here. Plus times minus is minus. Minus times plus is minus. That's over here. Plus times plus, this is the way that the machine doesn't work. Plus times plus, it doesn't give you the minus. This is simply the opposite of it. I have tried to explain something to you without using multiplication, but by showing you that this is the same principle. If you put the opposite together, it brings you the same result as if you give the same side of the batteries at the same side, right? That's the reason. It gives you the same result because it is exactly the mirror image. It's like looking into them. That's the reason why we have minus times minus. You can also say, I want to go down 1 floor. But the elevator is turned upside down. What will happen if I go 1 floor down in an elevator that is turned upside down? I will go to the bottom, right? But then it's up. That's why minus times minus is a plus. It's a miracle.
Yes, because
Do you accept it or not? We're going to try it again. Ground floor. go down 2 floors. Where are you? -2. Now I do the opposite. Why do I do the opposite? Because minus is the opposite. 2 is the opposite of -2. By turning it around, I make it a minus. I do the opposite. And I go up 2. You can see it, right? -2 becomes positive when I multiply it by -1. Because if I multiply something by -1, it will bring me to the opposite. Here is 0. Here is 2. If I multiply it by -1, it will bring me to the opposite. Sir, it's a miracle. But it works. And the only thing you have to remember is the rule. And the rule is minus times minus, or minus divided by minus, gives you a positive number. Another thing that you have to remember, and then you can forget it, you only have to remember it. Sometimes people use these strokes, and then it's called absolute value. It returns you the positive number of what is between the strokes. You can see over here, if 7 is between the strokes, then it remains 7, because that's the positive number. If it is -5 between the strokes, it becomes the positive number. It's called the absolute value. The absolute value is useful, because we often use it when we talk. We say something is a positive number, but we know that it is a negative number. So that's why it's often done like this. Positive number remains positive, negative number becomes positive. It's called the absolute value or the modulus. And for 0, 0 is neither positive nor negative, so then there needs to be another rule, especially for 0, because it's not negative and it's not positive. Okay, let's do this. So I ate my apple, but you remember, Peter eats many apples. The first thing we do is parentheses or brackets. There it says 8 plus 4 minus 17. So this becomes -5. 8 plus 4 is 12, minus 17. You're on the 8th floor, you go up 5, then you go down 17, you're at -5. Second step. All the multiplications and all the divisions. This is the first multiplication. 4 minus 4 times -3. Negative times negative is positive. 6 divided by -3. Negative divided, positive divided by negative, that remains a negative. And then we have 7 times -2 times -3. Negative times negative is positive. And then times a positive number, it remains positive. So there we go. 12, 6 divided by -3, -2. 7 times 2 times 3, that's 7 times 6, 42. 12, -2, -5, plus 42. You are on the 12th floor, you go down 2, you go down 5, you're at 5, and then you go up to 42. Now we're going to talk about fractions. Fractions are numerator divided by denominator. And the best way to remember it is this. A fraction of the whole. Below the stroke, there we have the whole. If we have a pi, we cut it in 4 pieces, we take out 1 piece, 1/4, then we know that the whole is 4/4, so it says a fraction of the whole. What does it look like? Can look like anything like that. 1/3, 0.25, 71%. Or this is something that your calculator sometimes tells you, 3.0 times 10 to the power minus 5. Small number, very small number. Or it's also written like this. These are all fractions. More on fractions here. If you're not good at fractions, go there, because that's a nice website, right? And the presentation is on Moodle. You will find there the link as well. Now, what do they look like, real fractions in life? Well, this is a pizza. It's in Rome. You can see, Italy, pizza cut in pieces. One shop next door. The pizza is not only like this, it's also like a square, right? What do we see in graphs? This is the pie chart. Everybody knows the pie chart. But that's exactly the same story, right? It's a bar chart. This is the same fraction as this fraction. It looks a little bit different, right? But it is the same. And you can all eat it. Now take a look at this. This is what you will often see. That people use stuff like this. Try to read it. Slim, can you try to read it? I got lost when I was here, and I'm a trained economist. This is the same story with then in the graph. Wouldn't it be wonderful if you could read the graph the same way that you can read the story? Because the graph is something that you can understand. You can see directly, this is the blue part, industrial and civic, 60%. It will take you 1/4 of an hour to find it out when you read the text like this. Okay, over here, this is special. They take this pie and then they make a subdivision. Again, you have the shares of this. We will talk about it later on. My point now is, very often, this is something in which you get stuck. And then when you try to make a table or a graph out of it, it will become much clearer. Of course, it needs a little bit of your business brain. When I train PhDs, I give them this exercise. I have one scientific article written by a professor, and I ask them, did you do it? I don't know what they did. I ask them to write down what the numbers are in the table. And it takes them half an hour. It's very good when you're a professor, you can take a break of half an hour, right? And they work, and then at the end I show them the table, and then they understand that they have to do it better. We will do it later. Now we're going to talk about fractions. This is easy. This is when we multiply a fraction with a number. I already did it sometime, and you did not oppose it. It says A2, the fraction of B to C, or A2 times B divided by C, and you can see that I multiply it, but it is easier to take a look here at the example. 3 times 2/5, 3 times 2 divided by 5, 6/5 is 1.2. See, I translate it directly into a decimal as well. Second example. Now I'm multiplying 2 fractions. Still easy. 2/3 times 3/4, 2 times 3, 3 times 4, 6 divided by 12, or 0.4. This is not the difficult part where you will get into trouble. If you multiply a fraction with something, it's easy. Do the same above the stroke and do the multiplication below the stroke. Where everybody gets into problem is here. That's when the number over here is different and we have a plus. But the trick that we follow is we want to make this the same kind of number at the bottom. How do I make the same kind of number without distorting everything? There's my friend 1. My friend 1 is a wonderful friend. Because if I multiply something by 1, it stays the same. 1 times 7 is? 1 times 0 is? Proves my point. Right? 5 divided by 5 is? That's my friend. 3 divided by 3 is? 1. That's my friend. See? I did nothing. I only was very clever. I used the same number in the numerator and the denominator. Now I multiply this 2/3 by 5 over 5, so that's 1. And I do the same over here, but then I do it with 3 over 3. Right? And then I have 3 times 5 is 15. That appears here. 3 times 5 is 15. 3 times 5 is 15. It's equal, right? That's what I want to do. And then over here we have 2 times 5 plus 3 times 4, 10 plus 12, 27. 27 divided by 15. That's 1 problem. So this is the first problem. You have to add up fractions which do not have the same sort of. If you do it on a machine, there's no problem. Right? If you do it on a machine, it will be decimal. No problem, you can handle it. Then there is an issue of division. That's also difficult. What I'm going to tell you is that if I divide by a fraction, I will do the same by multiplication. And the reason that I want to talk about this is also because I want to show you that multiplication and division are very much related. So what I'm going to do is I'm going to calculate inverse. Inverse is like flip over. Right? So here I have a division, divide. I'm going to divide by 2/3. I don't like to divide. Right? So I multiply by 3 over 2. See what I do? Division by a fraction is multiplication by the opposite. Now it's easy because it's multiplication. No problem anymore. Let's go back to Suriname. 12 divided by 3 times 4. Here it says 12 divided by 3. I have to divide by 3, so I can also multiply by the inverse. Right? I divide by 3, but I can also divide by, multiply by the inverse. So this is 12 times 1/3 times 4. You see that this is all multiplication. You go from left to right. 12 times 1/3 is 4, times 4 is 16. This is why my rule is right and why the other rule is wrong. Because multiplication by a fraction is division by the opposite. So it's time to make it dark again. So this is my baby brother, Jeroen. This is my middle brother, Bart. That's me, right? It's in 1985. See? 3 boys. This is my family, 2009. This is my wife, Hanneke. This is me. This is my oldest daughter, Doris. Vera, my middle daughter, and this is Eva. Eva just was on the phone. She has her final examinations at school. She wants to tell me the grade that she got. But you see, you are more important than Eva at the moment because I'm teaching. What is the probability, what is the chance, what is the fraction that we will have a situation like this? That's a place where we use numbers. If a baby is born and you don't know anything about it, what is the chance that it is a girl or a boy? Is it equal? Yes. So it's 1 out of 2 will be a boy or a girl, right? So, there we go. What is the chance that the second one will be the same? Also 1 out of 8. 1 out of 8. The chance that I will have 3 boys, 1 out of 8, or 12.5%. What is the probability that I have 3 daughters? The same. Why? Because at the beginning I asked you, what is the chance that it will be a boy or a girl? And once I have a boy, then I need a girl. Oh, not once I have a boy, then I need a boy to make the story go on. So that's 1 out of 2. See that there is a relationship between fractions and chances, and you know it, because if you're betting or if you're gambling, you know that there is a chance like 1 to 10 that the horse will win. 10% or 1 to 10. So now we're going to do 2 exercises. The first exercise is calculate 2/3 divided by 4. The second exercise is more difficult. Divide 2/3 by 4/5. Done? Two-thirds dividing by 4. Use the inverse. 4 over 1 becomes 1 over 4. Because multiplication is easier. 2 times 1 is 2. 3 times 4 is 12. 1, 6 is 0.16. If you do this on the calculator, it will say 0.166666666666666 goes on, right? Now this one. Calculate. That's difficult. Make it easy. Multiply by the inverse. 2/3 divided by 4/5 is the same as 2/3 divided by multiplied by 5/4. It's 2 times 5 divided by 3 times 4. 10 divided by 12. 5, 6. It will say 0.833333333. Yeah.
Why is it that if I use the phone, I get a different figure than that? If I say 2 divided by 3 times 4, yeah? Is that 10 divided by 3?
Yeah, but if you do this on the calculator, you have to tell the calculator. The calculator is stupid. Right? So for you it's important that you tell the calculator that it is not like 2 divided by 3 times 4, because that's what you're pushing. You have to use brackets. So for a calculator machine, you will have to divide 2 divided by in brackets. Or you do 3 times 4, you remember that you have to divide by 12. Right? Now we're on. Because you can see I stop somewhere, right? And that's what we often ask. Here it says 0.16, it doesn't fit anymore. It goes on, once, blah, 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 blah. Around the world, and it comes on the other side back. It never ends. So somehow we will have to do a little bit of rounding. And rounding is that we are going to replace a value in general by a shorter and a simpler expression. For example, 1.2346, we are going to say this is 1.2. Why? Because the rest is too small. For me it's easy. For me the reason is I cannot remember any number where I have more than 3 digits. Right? So 1.2, that's something I can understand, but 1.346, I get lost. Sometimes it's unavoidable, like P, right? So this room is P, but we stop 3.14. And sometimes it's logically required, because if I have €1 or $1 and I divide it by 3 people equally, everybody can only get 33 cents. Well, there's 1 cent over. You know what happens with the cents that are lost with rounding? That's the profit of the banks. Because they round off everything, right? So, what are the steps? The first question is, how many decimals do you have to round? This is often given. If you work with currencies, 2 decimals. Then the question is, if I want to do 2 decimals, what is the 3rd decimal? So that's the thing I'm not going to write down. That's where I take the look. If the 3rd, so the next digit, is 0, 1, 2, 3, or 4, I round towards 0, which means down. A positive number, it's also that it's up because it becomes less negative. So if I round 1.2 to 0 decimals, I go from 1.2 to 1. I'll go from minus 1.2, I go also to minus 1. So that's why we say towards 0. If it's 5, 6, 7, 8, or 9, we round away from 0. So that's rounding. There we go. First number. We want to round it to these 2 decimals. Easy. There are already 2 decimals. So we don't round it, right? This also easy. This one, I want to make 2 decimals. 1, 2, 3. I want to make 2 decimals, so the next one is 7. 7 is here. I'm going away from 0, so this becomes 89 becomes 90. So it becomes 0.90. This one. $12.38, right. Everybody with me? Okay. This one, 2 decimals. Minus 0.1, right? Good. This one, 1.0000499. This one, it's our room, 3.14. Not going to talk about it. 0.45989. 3 decimals. But this is not our room. First this one, right. What will it be? 0.460. Everybody with me? Yes. We do the room. 1, 2, 3, this 7, what does it mean? This becomes a 3. Very good. 98.56. We have to make 3 decimals. What do? We add a 0. Because we have to make 3 decimals. Over there. This one, 3 decimals. What does it become? 0.008. 1.3 million? 1.300 million. 1.000. Why? Because we have to write down 3 decimals. And this is what your calculator tells. You see, here it says 2 to the power O, to the power 0. Why is that 1? Just stay with me for a few moments, then I will explain it. 10 to the power 3, 1,000. This is not a comma like in the Netherlands we use a comma as the decimal point. It's not a decimal point, it means 1,000. It means with 3 zeros. You can see it's the notation. 6, then you're at a million. Here we have these are big numbers, and then we get into trouble because on the other side of the Atlantic they will use different words. In the USA it is called a billion, we call it 1,000 million or a million. Trillion with billions. You see that there is a lot of confusion. And then here they go on a quadrillion, a quintillion, billion, and trillion. Okay, so that's the only thing that you have to know is if you read words where it says billion, then you have to check what the numbers mean. Okay? And this is a very big number. They don't even need this number to write down the foreign debt of the United States, but they need this number, right? Because it's a really, really big international debt. Okay, now powers and rules. And now I'm going to tell you about the zero. So we go over here. First we start here. 2 to the power 1 means I have to multiply 2 by nothing. So that's 2. Here I have to multiply 2 by 2. That's 4. Here I have to multiply 2 by 2 by 2. That's 8. So there we go. If I move from here to here, I divide by 2. If I move from here to here, I divide by 2. When I move from here to here, I divide by 2. Now you can see where something that is to the power 0 is a 1. But it goes on. Same rule. If I divide by this, minus 1. If I divide again by 2, minus 2. See how it works? And this is why people in the past, when we didn't have calculators, loved logarithms. And they didn't love it because it was easy to make the numbers, but they loved it because here we have multiplication and division, but here we simply can add things, right? 1 plus 2 is 3. Much easier than having to do the multiplication. Not when it is with 2, but when it is with really big and difficult numbers, that's what it is. And this thing over here, if we want to know it, we use logarithms, but that's next time. Okay. Now roots. Everybody hates roots, but there's also a fun name in roots. This is square root day. So, it means we take a look at the month and the day and the year. So 1 January, the first year, the year 2001. That was the official square root day. Right? Second square root day. 2nd of February 2004. Right? 3 March of 2001. 4 April 2016. This is the day that the mathematicians are very happy, right? They live on roots. 5/5/2025. How will the steel is still around? 6/6/36. 7/7/49. 8 August 64. 9 September 81. And then it stops. Right. You can see what we do is we take the power and we take the root. And it's again, it's the same sort of thing, but we run it the other way around. Why is that? I showed you. Right? It's from the 1 to the above. It's over here. And I go, oh, sorry. When I go from here to here, I do the exponential. When I go from here to here, I do the root. So, was this boring? No? Was this frightening? Did you learn anything?
Yes.
I think you learned an awful lot. The most important thing that you learned today is don't be afraid of numbers. We are going to beat all those guys that use numbers. In the end of my course, you are simply able to see where they make their mistakes. You have to work, because you did not get the test, right? Don't wait until the last moment. Go to the library. Take a look at the books that are suggested. Start doing. If you know where your weakness is, start to work. I see you next week. Thank you.